Hello my dear students. Today we will study a very important topic of organic chemistry, that is carbonyl compounds. It is a very important topic for NEET preparation. So let's start. Carbonyl compounds. These are very important functional groups. Compounds which contain carbon-oxygen double bond are known as carbonyl compounds. Okay students, so compounds in which carbonyl carbon is bonded with hydrogen are known as aldehydes. This is the simplest aldehyde known as formaldehyde, and 2-carbon aldehyde is known as acetaldehyde. Commonly it is known as acetaldehyde. Students, we have seen that in both the compounds our carbonyl carbon is bonded with hydrogen atom, and when carbonyl carbon is bonded with another carbon, then it is known as ketone. The simplest ketone is 3-carbon ketone, which is known as acetone. We will see some more examples of ketone. Let's see another example. CH3, CH2, COCH3. It is 4-carbon ketone, and in this ketonic group is present in middle. So this is known as butanone. What it is called, students? Butanone. Now the next category of carbonyl compounds in which carbonyl group is in middle and carbon is attached with another oxygen atoms. Then this is known as carboxylic acid. When carbonyl carbon is bonded with oxygen and another carbon atom, then these are known as esters. When carbonyl carbon is bonded with oxygen atom and another acyl group, then these are known as anhydrides. Next example, in which our carbonyl carbon is bonded with nitrogen atom. This is our carbonyl carbon. When it is bonded with nitrogen atom, then these type of compounds are known as amides. Next, in which carbonyl carbon is bonded with halides. X is halogen. These may be HCl, Br and I. These type of compounds are known as acyl halides. So students, we have seen that we can divide our carbonyl compounds broadly in two categories. Carbonyl compounds can be divided into two categories. First one is aldehydes and ketones, and next category is carboxylic acids and their derivatives. Carboxylic acids and their derivatives. Let's start our study with first category, that is aldehydes and ketones. Firstly, we will study its nomenclature. After this, we will study their methods of preparation. Okay, students? So let's start nomenclature of aldehydes and ketones. Let's start with first example. This is SCHO, which is the simplest aldehyde. Commonly it is known as formaldehyde. So students, how can we give its IUPAC nomenclature? We all are very much familiar with IUPAC, that is International Union of Pure and Applied Chemistry. On this basis, how can we name this compound? So for naming of this compound, what we have to do? We can give the name of this compound on the basis of its parent alkane. So this is one carbon, so the parent alkane is methane. What we have to do? We have to replace and remove the suffix E by ale. So what is the meaning of this equation? You have to replace the E of alkane by ale. So what it comes? It is alkenyl. So what is the name of this compound? This is methanol. Very good. The next compound, that is our acetaldehyde. Yes, students, there are two carbons, so it is called ethane. Parent alkane is ethane. So the name is ethanol. Yes. The next, when we have taken 3 carbon, the name of this compound is, yes, propanol. What it is called? Propanol. Yes, students. Now let's start the naming of our second category, that is ketone. And we have already studied the simplest ketone is acetone, which is a 3 carbon ketone. So how can we give its name, IUPAC name? Commonly it is known as acetone, which is a very important laboratory solvent. So for naming this simplest rule which you have to follow, you have to eliminate or replace this E by on. You have to remove its E by on. So it is a 3 carbon alkane. So the name is propanone. The name of this compound is propanone. The next ketone is CH3, CH2, CO, CH3. Here you have to locate the position also, because our ketonic group present in middle. 1, 2, 3, 4. What it is called? It is 4 carbon alkane. That's why the name of this compound is butanone. So when we locate the position, the name becomes butane 2-on. Now, what will happen when we take the example which contain both aldehyde and ketonic group in the same compound? Let's see. CH3, CH2, CO, CH2 and CHO. It contains ketonic group as well as aldehydic group. So what will happen now? We have to give the priority to aldehyde over ketone. So our functional group in this is aldehyde, which get priority over ketone. Now your ketone will act as substituent, and when ketonic group act as substituent, it is known as oxo. So let's start the naming of this compound. 1, 2, 3, 4, 5. So the name of this compound is pentanal. But which pentanal? Where on third position there is the substituent oxo. So the name of this compound is 3-oxo pentane 1-ale. Now I think now it is clear, students. So this is the nomenclature of aldehydes and ketones. let's see some another example of aromatic aldehyde. This is the aromatic aldehyde. We can write it like this: C6H5CHO. It is known as benzaldehyde. The name of this compound is benzaldehyde. If we will take another example, this is our ketone. The name of this compound is acetophenone, and when we will give its IUPAC nomenclature, it is called 1-phenyl ethanone. What it is called? 1-phenyl ethanone. So it's all about the nomenclature of aldehydes and ketones. Now we will study some methods of preparation of these carbonyl compounds, which are of first category, in which carbonyl carbon is bonded with hydrogen and carbon. So let's start methods of preparation of these carbonyl compounds. Let's start with first reaction, that is by alcohols. How can we prepare our carbonyl compounds by alcohols? So from primary alcohol, how can we prepare? These can be prepared by oxidation of this primary alcohol. This is 1 degree alcohol, primary alcohol, and the name of this alcohol is ethanol. When we use mild oxidizing agent CrO3 plus pyridine, then we will able to get acetaldehyde. Similarly, when we will use secondary alcohol, that is isopropyl alcohol, with the help of this mild oxidizing agent, that is CrO3 plus pyridine, we will be able to get acetone. Now, the second procedure by which we can prepare our aldehydes and ketones from alcohols are by dehydrogenation of alcohols. So let's see the first example, that how can we prepare our carbonyl compounds from alcohol by dehydrogenation. CH3, CH2OH, that is our primary alcohol, ethanol. We have already discussed about this. We can use metal, and by this catalytic dehydrogenation, you will be able to get CH3, CHO. This is acetaldehyde. When we use isopropyl alcohol, and by its catalytic dehydrogenation, we will be able to get acetone. So this is our acetone. So this is the common method for both aldehydes and ketones. Next preparation. How can we prepare our carbonyl compounds from fatty acids? So let's see the second method of preparation of carbonyl compounds from calcium salts of fatty acids. in this category. First of all, we have selected calcium formate. When we perform its dry distillation, we will be able to get formaldehyde as well as calcium carbonate. Very simple reaction, students. So, when we use calcium acetate in place of calcium formate, you will be able to get ketone, that is again acetone and calcium carbonate. Now the question arises in your mind, what will happen if we will take mixture of both the fatty acids? Let's see what will happen in this case. When we have taken mixture of both the fatty acid, that is calcium formate as well as calcium acetate. In this case, you will be able to get acetaldehyde. Two molecules of acetaldehyde and 2 molecules of calcium carbonate. This is a very important reaction, students. How can we prepare our aldehydes and ketones? By vapors of fatty acids. This is the another reaction. When we use fatty acid formic acid, by catalytic decomposition of this fatty acid, you will be able to get FCHO, formaldehyde, CO2 plus water. Now, if we use CH3COOH plus CH3COOH, then you will be able to get ketone. What will happen if we will use mixture of both the fatty acids? In this case, again you will be able to get acetaldehyde. This is our formic acid, and the another fatty acid which we have used is acetic acid. What will happen in this case? You will be able to get acetaldehyde, carbon dioxide and so by fatty acids we can prepare both aldehydes as well as ketone. Now let's see the another method of carbonyl compounds preparation. This is from Grignard reagent. How can we prepare these carbonyl compounds from Grignard reagent? Students, you are very much familiar with the formula of Grignard reagent. This is our Grignard reagent in which metal possesses positive charge and carbon possesses negative charge due to difference in their electronegativity. When it is treated with hydrogen cyanide, what is this? This is HCN, hydrogen cyanide, and we know that carbon has electropositive charge and hydrogen possesses electronegative charge. When it is treated with this, simply you have to attach positive center with negative and negative center with positive. And you will be able to get this compound. Now you have to perform the hydrolysis on it. We have taken 2 molecules of water and you will be able to get RCHO plus ammonia plus MgOH. So by this we can prepare our aldehyde. But you can't prepare formaldehyde by this. Why? The reason is very simple, because HCl already contains 1 carbon and your Grignard reagent also contains 1 carbon. So the lowest or simplest aldehyde which will form by this reaction is acetaldehyde. Now, what will happen if we use RCl in place of HCl? Very simple. You will be able to get ketones by this reaction, RCOR. Now, how can we prepare our carbonyl compound from chain.The? Very interesting reaction. When we use chain.The, this is our next preparation, chain.The. When both the halogen atoms are present on terminal carbon, then you will be able to get, you have to perform hydrolysis on it and you will be able to get this type of structure. And we know that when 2 hydroxy molecules are present on 1 carbon, this compound is unstable. So you have to perform dehydration here. When we perform dehydration, you will be able to get aldehyde. I think there is some problem. So we can write it here, RCHO plus water. I think it is clear now. What will happen if we will take chain.The in which both the halogen atoms are present in middle? Perform hydrolysis on this. Unstable molecule, you have to eliminate 1 water molecule from here and you will be able to get ketone. So this is the another method by which we can prepare our carbonyl compounds, both aldehydes as well as ketone. Now we will consider the methods which are used to prepare aldehydes only. In this category, the first method which we are going to study is very simple method given by Stephens. So let's see the Stephens method of reduction. When we use tin chloride in combination with HCl, what will happen? First of all, it forms andamine. Catalytic hydrogenation we are going to perform here in presence of tin chloride as well as hydrochloric acid. It forms andamine. Intermediate, also known as Schiff base, very important intermediate in organic chemistry. So now what you have to do? You have to perform its hydrolysis and you will be able to get aldehyde as well as ammonia. So this method we can use for aldehyde only. This is known as Stephen's method. What it is called? Stephen's method. Very important reaction. Let's see the another method of synthesis of aldehydes only. Very important reaction of organic chemistry, that is Rosenmund reaction. What is the name of reaction, students? Rosenmund reduction. Rosenmund reduction. For this purpose, you have to take acid halides. What it is? Called RCOCl. These are known as acyl halides. These acyl halides, when undergo catalytic hydrogenation or catalytic reduction in presence of palladium PaSO4 in boiling xylene, what will happen? It will form RCHO plus HCl. So this is called another method of preparing aldehyde. Here palladium is used as catalyst and for stopping the reaction at this stage on aldehyde only, otherwise it will convert into alcohol. So we have to use some catalytic poison. Here we have used barium sulfate for this purpose, and boiling xylene here react as reducing agent. So this is the another important method for preparing our aldehyde. You know that what is boiling xylene? This is toluene. When another methyl group present at ortho position, this is called xylene. So all these methods are used for preparing aldehydes only. In the next lecture, we will study about the methods which are used to prepare ketones only. All for today. Thank you, students.